All right, guys, here we go. Here we go. All right, guys, focus, 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 focus. An equation involving a derivative is called a differential equation. The order of a differential equation is the order of the highest derivative involved in the equation. We're going to be dealing with primarily first order. We'll let your Diffie-Q class talk about homogeneous second order equations, damped, undamped systems, all that good stuff. So this is just at the beginning, right? The intro. We're just scratching the iceberg here. Is that a saying? Scratching the iceberg or tip of the iceberg? All right. Yeah. Here we go, guys. Here we go. So this is what you're used to. You've done plenty of these. They're not too extreme. Those are pretty basic, right? So they're telling you what the derivative is. The dy dx is secant squared x plus 2x plus 5. And it says find all functions of y. You've done this many times. So this is y equals, and you're just doing antiderivative. Antiderivative of secant squared is tan x. Antiderivative of 2x is x squared. Antiderivative of 5 is, and then you write plus c for some constant c. And those are the ones that we've been doing all this time for some constant c. If you don't put the plus c, it's wrong, right? Because it says find all functions. And they all differ by some constant. Don't worry, next time we'll do slope fields and all that good stuff. But we're just starting out, guys. We're not going to do all this packet if you're thinking like, oh my God, we're going to do all this today. No, this is over 2 days. All right. Solve an initial value problem. Relax. You've done this already. So find a particular solution to the equation dy dx equals e to the x minus 6x squared whose graph passes through the point 1, 0. That 1 is an x. That 0 is a y, right? So you're just going to say, okay, antiderivative. Antiderivative of e to the x is just e to the x. Antiderivative of 6x squared is, let's see, add 1 to the 2, so that's 3. Divide by 3. 6 divided by 3 is 2, so 2x cubed. Let me know if you guys have any questions. Plus c. And then we just plug in our initial value, guys. That's a 1, that's a 0. So that's a y value. So 0 equals e to the 1 minus 2 times 1 cubed plus c. Get the c by itself. So I'm going to move e to the left and this to the left. So c equals 2 minus e. So what is my equation? My specific equation is e to the x minus 2x cubed plus 2 minus e. If I take the derivative of this, yes, I do get e to the x minus 6x squared. And there it is. That's it, guys. Cool or not cool? Okay. So here's where the differential equations that you're probably going to see on a free response come out. These are called separable differential equations. Look, a differential equation in the form of dy dx is f of y times g of x is called separable. We separate the variables by writing in the form, blah, blah, blah. The solution found by answer differentiating each side with respect to its thusly isolated variable. Okay, Chop, what does that mean? Group the y's with the y's, the x's with the x's. That's all it means. So when you have something like this, so I'm going to go slow, guys. It says solving by separation of variables. Solve for y of dy dx equals. So the first thing I'm going to do, law of exponents. I'm going to go dy dx equals x squared y squared. Are we okay with that first step? Next step, I'm going to divide by y squared and I'm going to multiply by dx. So I'm going to write it like this. Dy, how should I write it? I'll write it right for now like this. Dy over y squared equals x squared dx. Do you guys see what we did? All right, now that we have, this is a y, it just came out kind of like what? All right, now that we have it like this, I'm going to go ahead and move this up to make it easier to take an antidifferentiation, to take an antiderivative. I'm going to integrate. And then you're going to say, okay, well, let's see, antiderivative. Y to the negative 2, add 1, divide. So negative 1 over y. And you can, if you want, okay, don't write this down because write it down. Plus C1 equals, antiderivative of the right-hand side, x cubed over 3 plus C2. All right, this is probably the only time you'll ever see me do that. You see how this is a constant? This is a constant. If I go minus C1 and I go minus C1, isn't C2 minus C1 just some constant? So sometimes some professors will write C3. I've never been a fan of that. We're just going to leave it like this, and we're going to let the situation tell us what that constant is going to be. So if you want to be a robot, just put the C with the X's. Chop, I don't understand what's going on. C2 minus C1 is just some constant, guys. You don't have to be doing this over and over again. Write a constant subset of 1, subset of 2, subset of 3. We'll let this situation tell us what that constant is. So what do? I know when y equals 1, x is 1. Do you guys see that? So I'm going to sub x equals 1, comma, y equals 1. So negative 1 equals 1 to the third power over 3 plus c. Move this 1/3 to the left. Negative 1 minus 1/3 equals c. So let's see, 3/4. So negative 4/3 is c. We're still okay? So I'm going to write this expression again, this one right here. I'm going to go negative 1 over y equals x cubed over 3 minus 4/3. I'm just doing algebra now. Man, do I have space? Okay, I'm going to write at my top of my margin here, but hopefully you have more space than yours. 1 over y equals x cubed minus 4 over 3. I just combined because they had the same denominator, 3 and 3. I'm going to move that negative. So I'm just going to, let's see, what am I going to do? Times negative 1 times. So here's what I have. 1 over y equals 4 minus x cubed over 3. Child, why'd you do that? I like to have the positive one in the front. So because sometimes the negative floats and it looks like the whole expression is negative. And then, okay, I'll stop. I want y equals, I have a fraction on the left, I have a fraction on the right. I can just go, choo. So y equals 3 over 4 minus x cubed. And there it is. How do we feel? Ask me, Salali. Ask me. All right. Don't worry. We're not going to do the whole thing, guys. We're probably going to stop right here on this one. Let me see. What's the next one? Yeah. All right. So here we go. So you can already see what UH quiz is going to come next. If you want to get ahead of it, I don't have a due date just yet. All right. Use integration to find the general solution to the differential equation dy dx equals 4x times x minus 1. So for this one, guys, go ahead and distribute. You don't want to use, any special. Dy dx equals 4x squared minus 4x. Okay. Antiderivative. We're not doing anything fancy here. If you want, multiply by dx, you can, but there's no two variables on this one. So I'm just going to go y equals 4x cubed over 3 minus 4x2 divided by 2, so 2x squared plus c. I don't see any issues, so let's just look for that. It looks like it's letter A, unless I messed up. Nope, that looks like it's it. And that's it. What do you guys think? Not bad, right? Okay. Example 5. This time, what is different about example 5, guys? I have a what in there. I have a y in my dy dx. Do you guys see that? So this one, here's how you do it. This is how you do it in the free response. I guess it doesn't matter in the multiple choice, but in the free response, guys, it has to look like this or you're not going to get a point. You're not going to get the point. Get the y's with the y's, the x's with the x's. So you're going to multiply by y plus 5. Whatever you do to one side, you do to the other. And you're going to multiply by dx and dx. So here it is. It's going to look like this. Y plus 5 dy. If you don't want to put the parentheses, that's fine. It's understandable. X minus 3 dx. Are we still okay? All right, next. What's my next move? Well, I want to get rid of that dy and dx. Integrate. So now you're going to have y squared over 2 plus 5y equals, Chav, where's the c? I'm going to put the c with the x, guys. X squared over 2 minus 3x plus c. So get it to here. Notice all my answer choices do not have a fraction. I'm going to put a giant parenthesis on all this, and I'm going to multiply it by 2. So here we go, guys. Y squared plus 10y equals x squared minus 6x plus, don't write 2c. How come I didn't write 2c? A constant times 2 is still a constant. Just write plus c. A constant times 2 is still a constant. Make sure that we understand that, guys. All right, next move. Let's see, what's my next move? I guess my next move, guys, is move these to the left, and then we'll see if we have to change polarities or not. So here's my answer. So I see negative x squared plus y squared. Let's see, what do they have next? So x plus 6x, and let me know if I'm writing it wrong, plus 10y equals c. So I'm going to look for that first. Negative x squared plus y squared plus 6x. Oh, what happened to the 10y there? Out. Out. Negative x squared plus y squared plus 6x plus 10y equals c. There it is. Sometimes you have to change the polarities again one more time, but we didn't have to do it that time. We still okay, guys? All right. Here we go, guys. Here we go. Guys, focus. All right. Divide, guys. Divide by secant y times by dx. So here we go. We're going to have, let's see, dy over secant y equals 1 over x minus 3 squared dx. Does everyone know how we got here? Oh, what do you mean? We want all the y's together, all the x's together. All right. No, I guess. These are separable differential equations, guys. The y's with the y's, the x's with the x's. That's what we said over here. Look. All right, guys, focus. Okay. Next move, guys, we should know a little bit of pre-cal. 1 divided by secant y is the same thing as cosine y. I hope that we are at the level at the moment. Hope by now we've done like at least, hundreds and hundreds and hundreds of antiderivatives by hand, hopefully. Integrate. So here's what I have. I have sine y equals, and hopefully we've done enough. Look, this is a squared, x minus 3 squared. You don't need to do u sub unless you really want to. Negative 1 over x minus 3 plus c. Yeah, you guys have done a lot of antiderivatives. Hopefully by now we know it's like negative 1 over x squared, right? Add 1, divide. Okay, I'll show you guys. All right. I don't think this is one of those that requires u sub, but if you wanted to, u equals x minus 3, du equals dx. So then this turns into 1 over u squared du. So that's the same thing as u to the negative 2, antiderivative, add 1, divide by that number, negative 1 over u. So negative 1 over u plus c. So there it is, negative 1 over x minus 3 plus c. But by now, some of these should be starting to turn out into automatic, guys. If they're not automatic, that means that you haven't done enough. You're not prepared enough. You need to do more. So please make sure you do the antiderivatives by hand whenever possible. All right, so there it is. And let's just look for this answer. So there it is. All right, here's what you're doing today. Did they give it to me? Okay, they don't. Here's what you're doing today, guys. We do have a delta. Okay. All right, guys, focus. Given the differential equation, dy dx equals 2x minus 5 over y, find the particular solution, y equals f of x, with the initial condition f of 4 equals 2. All right, this is the same thing as just saying 4 comma 2. Multiply by y, multiply by dx. So here's what you're going to have. Y dy equals 2x minus 5 dx. You don't have to put the parentheses, but if you're one of those, it's like, oh, I need to have it. That's fine. Put the parentheses. The dx just indicates that's the end, right? When you're going to do the antiderivative. All right, here we go. Integrate, integrate. So you're going to have y squared over 2 equals 2x squared divided by 2, so that's x squared, minus 5x plus c. It depends on where you want to use your initial condition. I like to just use it immediately. That's just my habit. I'm going to plug in the 4, 2 immediately. So the 4 is an x, the 2 is a y. So 2 squared over 2 equals 4 squared minus 5 times 4 plus c. Are we still okay, guys? All right. 2 squared is 4. 4 divided by 2 is 2. Or I guess you could just cancel, right? So 2 equals 4 squared is 16. 5 times 4 is 20. Haven't done anything crazy, guys. 16 minus 20 is negative 4. So when you move that to the other side, c is 6. Let me know if everything checks out. Plus 4 plus 4. From there, guys, plug in the c right there. Y squared over 2 equals x squared minus 5x plus 6. You're just doing algebra, guys. This is why your algebra is important. Times 2 times 2. So we can get rid of that 2 in the bottom there, right? So you're going to have y squared equals, that's times 2, not that to the power 2. 2x squared minus 10x plus 12. Then Then I got to take a what? Square root, square root. Usually it's plus minus, but luckily our y value was positive. So y equals the square root. I guess I'll put it plus minus. 2x squared minus 10x plus 12, so we can have a good habit. Bless you, whoever sneezed. And you're going to circle the positive one. Why the positive one? Because when x is 4, the output better be positive 2. So let's see if it works. I'm going to put check. So square root 2 times 4 squared minus 10 times 4 plus 12. Let's see. 4 squared is 16. 16 times 2 is 32. I'm just checking. 32, 10 times 4. Is that a 4? 10 times 4 is 40 plus 12. So negative 8 plus 12 is 4, and the square root of 4 is 2. It works. When x is 4, y value is 2. It works. This is your equation right there. Okay. One last one. Yeah, if your algebra is weak, it's possible you can have a lot of trouble with this, guys. I put the solution at the bottom left-hand corner because the answer is going to look weird. Look how ugly this answer is. It doesn't have to look like that. That's just the answer. That's just the generic answer that Delta had. So let's see if we get that generic answer there. I'm going to go slow, guys. You guys ready? I'm going to go slow. dy dx equals e to the x plus 2 times 2 minus y squared with initial condition y of negative 2 equals negative 2. You guys ready? Here we go. The x's with the x's, the y's with the y's. dy over, I have to divide by 2 minus y squared. 2 minus y, close it, squared, equals e to the x plus 2, dx. Have I confused anyone? Here we go. I'm a little scared right here. What happened, miss? I divided by 2 minus y squared, so you have to put it in the bottom. See? It's yeah, I gotta divide by 2 minus y squared, divide by 2 minus, so it stays, it's like gonna go on the bottom. And this is like this over 1, you want to call it that. Times dx, so dx plus 2 times dx. All right. Here we go, guys. Here we go. I'm going to go slow. Integrate. And I'm going to go as slow as I can. So this will be 1 over 2 minus y. In reality, and I'm going to go slow, guys. Let me tell you what I just did. Okay, focus. I added 1. Remember, think about this as u substitution. So that would have been to the negative 2. Negative 2 plus 1 is negative 1. So 2 minus y to the negative 1 divided by negative 1. But look, chain rule, there's a negative in front of the y. So negative times a negative is a... Do we see how we got it? Okay. Or do you want me to do u sub so you guys can see it? Okay, let me do u sub here on the side. All right, guys, look, you got it. Focus, guys. I'm doing u sub here on the side. U equals 2 minus y. Du equals negative dy. Yeah, the derivative of y with respect to y is 1, right? So if I rewrite it, integral 1 over, I'm doing it with respect to, so I need a negative. Negative on the outside, u to the 2, du. Do you guys see what I did? And then look, so that negative is that negative, u to the negative 2 du. Negative, that negative is that negative, u to the negative 1 divided by negative 1 plus c. So negative times a negative is a positive. Add 1, divide by the number. Add 1. Antiderivatives. Okay. All right, here we go. Equals e to the x plus 2 plus c. Antiderivative of e to the x is e to the x. So antiderivative of e to the x plus 2 is e to the x plus 2. I'm going to plug in this. Maybe they're being nice. Negative 2, negative 2. I'm going to plug it in. 1 over 2 minus negative 2 equals e to the negative 2 plus c. I'm slowing down, guys. I'm going as slow as I can. 1 over minus a negative, so that's you're going to add them up. Fourth equals e to the 0. E to the 0 is, it's not 0, 1 plus c. So I'm going to move that to the left. 1/4 minus 1 equals c. So 1/4 minus 1 is a negative 3/4. And now slow down. Okay. This number, plug it in right there. Hopefully there are no mistakes. 1 over 2 minus y equals e to the x plus 2 minus 3/4. We can go so many different ways. I'm going to take a hint by looking at the answer choices. Oh, okay. They did it. They were lame. I would have thought they would have done common denominator. All right, you guys ready? I was about to go 4 over 4 to make one fraction, but looking at the answer, they didn't even bother doing that. So this is like saying that over 1. Yeah, I actually don't like their answer at all, but that's fine. You guys ready? Okay, I don't like their answer because it looks ugly to me. Instead of writing 4 over 4, you could have done a common denominator there, but this is like something over 1, and this is 1 over 2 minus y, so that means I can, there's an equal sign in the middle, so that means I can flip them both, and there would still be equivalent. Does that make sense to you? Yeah, a over b equals c over d, you can flip them. B over a equals d over c. All right, so here it is. So I have 2 minus y, and like I said, I don't like their answer, but that's fine. 2 minus y over 1, if you want to write it, equals 1 over e to the x plus 2 minus 3/4. I don't like it, but that's fine. So 2 minus y over 1, I can just delete that minus 1 there, right? Anything divided by 1 is itself. How do I move the 2? Subtract. Yeah, just subtract it. Negative y equals 1 over e to the x plus 2 minus 3/4 minus 2. Last move. How do I remove that negative in front of the y? Multiply both by negative. So look what they have. Y equals, I'm going to turn that negative 2 into a positive, 2 minus that fraction. 1 over e to the x plus 2 minus 3/4. And there it is. I don't like it. I think it's nasty. But that's how they did it. I was tempted, in case you're wondering what I was tempted to do, this. Minus 1, I was tempted to go 4 over 4 like this and make one nice little fraction. 4 e to the x plus 2 minus 3 all over 4. Do you guys see what I wanted to do? But I didn't do that. All right, is that the last one that I said we were going to do? Yes. All right. All right, guys, log into Delta, practice. You just need to practice now. So here it is, guys, round 2. I'm going to start while some of you are looking for it, guys. It says, consider the differential equation dy dx equals x squared y squared with a particular solution having an initial condition y negative 3 equals 1. So here's my initial condition. I'm going to write it over here on the side, negative 3 comma 1. Use the equation of the line tangent to the graph of f at the point negative 3, 1 in order to approximate the value of f of negative 2.8. So this is a lot like linearization, guys. Linearization. I don't know if you remember, we did it in the fall semester. All they're doing is they're using a tangent line to approximate the value. So I don't know if you remember, we had a curve and then you find that tangent. And as long as you're really close to the tangent line, that tangent line approximates this curve really, really well. As long as you're close to the point of tangency. See, the further away you move, the worse your approximation is going to be. Does that make sense? So that's all you're doing. Find a tangent line. What's up, miss? Oh, it's not working on this. Yes. Sorry. You can see it's been pretty easy. All right, guys. Focus. All right, here we go. Find tangent line. We find tangent line by doing a point and a slope. We already got the point. Use the point to find your slope. I'm going to write dy dx evaluated at negative 3 comma 1 equals parenthesis negative 3 close it squared times 1 squared. See? So negative 3 squared is just 9, so my slope is 9. So here's my tangent line. Y minus 1 equals 9 parenthesis x plus 3. Use this tangent line, to approximate. So what am I going to do? I'm going to move the 1 to the other side. I'm going to say f of 2.8 is approximately, I'm going slow, guys, 9 times negative 2.8 plus 3, close it, plus 1. Supposedly, we should be able to do this without a calculator. If you have a calculator, what's the point of approximating? You can just find the equation, plug in your actual 2 points, right? So let's see if we can do this without a calculator here. 9 times negative 2.8 plus 3, I believe that's 0.2 plus 1. 9 times 0.2 is 1.8. Wait. Yes, 1.8 plus 1. So there it is. That's my approximate. Oh, funny. Let this right next to. Oh, wait, is that positive? Yeah. 0.9, 9.2, 1.8, 1.8 plus 1, 2.8. Okay, 2.8. That's fine. That's what it came out to be. I just don't like that it's the same value as that, but that's fine. Oh, that's a negative. But the answer is correct. I just didn't put a negative in the negative 2.8 there. Because I put a negative in here, but I didn't put it. All right, we're good, guys. What do you guys think? Not bad, right? I think that's the same thing we're doing again. Yeah, but this time it's in context. It's a contextual question. So contextual questions are coming back in, guys. That's area under the curve and all that good stuff, interpreting them. Okay, we'll go slow. The quantity of a substance can be modeled by the function h of t that satisfies the differential equation dH dt equals 1 over 80 times h minus 160. What does h stand for? 1 point on this function at h of 1 equals 720. The quantity of a substance can be modeled by the function h. Okay, so the quantity of something, who knows what. Based on this model, use a linear approximation to the graph of h at t equals 1 to estimate the quantity of the substance at t equals 0.9. Okay, find a tangent line at t equals 1. Here's my point. This is the point, guys. 1 comma 720. This value is your t. This value is h. I need a slope. So I'm going to write dh, bless you, dt at 1 comma 720 equals 1 over 80, giant parenthesis, 720 minus 160. Have I lost anyone, guys? All right, here we go. 1 over 80 times, let's see, 72 minus 16, 72, 62, 52, 56, 560. Let me know if I made a mistake. I make mistakes all the time. Are we still okay? How many times does 8 go into 56? 7? 7? So this is 70. I don't think we made a mistake. Are we okay so far? All right, there's my slope. Here we go, guys. Oh, 7. Yeah, 1 0 1 0 7. I was testing you guys. Here we go. There's my slope. Y minus 720 equals 7 parenthesis x minus 1, or I guess technically h minus 1, or x. That's a t, and this is an h over here. So I'm going to write h of 0.9 equals 7 parenthesis t is 0.9. So 0.9 minus 1, close it, plus 720. Let's see what this is. And I really shouldn't say equals. I should say approximate. You're fine if you say equals. They're not going to take points off. 7 times 0.9 minus 1, I think that's a negative 0.1 plus 720. And 7 times negative 0.1, that's a negative 0.7 plus 720. And we should be able to do this without a calculator, guys, hopefully. So that is 719.3 of whatever quantity this is. How are we feeling? Okay. Let's go to the next one. Bless you. Bless you square. Okay. You're about to find out. Have you guys done half-lives in environmental science and chemistry and physics? You're about to find out where that equation comes from. It all comes from this. You have probably solved enough exponential growth problems by now to recognize that they involve growth in which the rate of change is proportional to the amount present. The more bacteria in the dish, the faster they multiply. The more radioactive material present, the faster it decays. The greater your bank account, assuming it earns compounded interest, the faster it grows. The differential equation that describes this growth is determined by that for everything, guys. The amount of money you have in the bank, the amount of bacteria, the population. Well, population sometimes logistics. Radioactive decay, half-lives. Everything is described by this. But the textbooks you read, they don't show you the differential equation. They just give you the models. But all the models come from this. We're going to show you where that model comes from. We're going to do it from scratch. And then we can solve this equation by separating the variables. Do I go right into separating the variables? Okay. Look at that equation. We're going to show you this. And don't worry, guys. That's fine if you don't get it, but I want you guys to at least see it. dy dt equals ky, where k is some constant. If it's growing, k is positive. If it's decaying, k is negative. Let the situation determine what your k value is. I would just wait until the very end to see what it is, right? Multiplied by dt and divide by y. So I'm going to write dy over y equals k dt. Have I confused anyone? If I want this to be a model, I want to get rid of the dy and the dt. I'm going to do that by, and then look what I get. I get ln, absolute value of y, equals kt plus c. Are we still okay? All right, I'm trying to solve for y, so I don't want ln there. So I'm going to go e, all of this. And then this turns to absolute value of y equals e to the kt plus c. Look how beautiful this is. I think this is just one of the most beautiful equations. Your law of exponents right here. That is just e to the kt times e to the c, where e to the c is just some constant. It's just some constant. So I'm going to go ahead and drop the absolute values, and I'm going to let the situation tell you whether the constant is positive or negative, right? So I'm going to write y equals some constant, e to the kt, and then, child, why'd you drop the absolute values? I'm going to write let situation determine positive, negative. Of course, when you're solving for k, if it's gross, it'll be positive. If it's decay, it'll be negative. But we'll let the situation determine that. Or you can put a positive or negative right off the bat. And there it is, guys. It doesn't have to be E. It could be any base. You'll see right now when we do the WASP problem. See, growth constant if K is positive, decay constant if K is negative. Let situation tell you. Let situation tell you. Tell me what, Chav? Whether it's positive or negative. Okay. All right. Look how awesome this is. Look at all this science and physics and chemistry here, guys. When an atom emits some of its mass as radiation, the remainder of the atom reforms to make an atom of some new element. That's at alpha and beta decay. Did you guys study that in chemistry? Alpha 01, beta 42. Hmm. Okay. Okay. I'm assuming this is freshman chem. I want to say it is. I'm not sure. At the university. Yeah, just whenever you get a chance, look up alpha and beta decay. If you're anything in medicine, you're going to be taking about it. Did you guys do this over there at your intern? You didn't talk about alpha and beta decay? Okay. The process of radiation and change is radioactive decay, and an element whose atom goes spontaneous through this process is radioactive. Radioactive carbon-14 decays into nitrogen. Radium, through a number of intervening radioactive steps, decays into lead. So you keep decaying into different things, right? Experiments have shown that at any given time, the rate at which radioactive element decays, as measured by the number of nuclei that change per unit of time, is approximately proportional to the number of radioactive nuclei present. So what does that mean? That means it changes by by the proportional amount that you have present. Thus, the decay of radioactive element is described by the equation. See, so this is why we can model it the way we modeled it. If why not, this is what usually they call this why not. Why not? And it's a play on words, guys. It's not literally why not. It's the letter Y, and then they call the zero not. Sometimes they call it initial. So if y naught is the number of radioactive nuclei present at time zero, the number still present at any time later t will be given by that equation, where t is greater than zero because we're talking about decay. The half-life of a radioactive element it has a negative there, so that's what I'm going to say. Negative with the k greater than zero is decay. The half-life of a radioactive element is the time required for half of the radioactive nuclei present in the sample to decay. I know you've definitely talked about half-life because that's part of AP Environmental Science. I believe that's part of that curriculum. And it's definitely part of chemistry as well. And physics. Well, it touches all examples. Example 7 shows the surprising fact that the half-life of a constant depends only on the radioactive substance and not on the number of radioactive nuclei present in the example. You'll see when we do. Are we doing that right now? Okay, let's do it right now. Find the half-life of a radioactive substance with decay equation, blah, 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 and show that the half depends only on K. Okay, I'm not a big fan of showing that negative K there. I guess that's fine. Okay, half-life. If you have half of something, so what they're telling me here, guys, is they're telling me to solve for the half-life equation, and they're saying when I solve for the half-life, I'm only going to have K and not the initial amount. It doesn't matter how much you have. That's what they're telling me. So look, if you have half of something, that's this. 1/2 y naught equals y naught e to the negative kt. See? So this is half of what you started with. Because see, it says half times y naught. Does that make sense to you guys? All right. If I wanted to solve for t, so I'm going to say solve for t. Solve for t. If you wanted to solve for t, the first thing you do is you cancel out those why nots. And then I want to bring that exponent down. It is actually what we're doing in pre-cal right now. So how do I bring that exponent down? ln. I heard someone say ln. Awesome. I use ln because I have the base e. You could have also used log, but use ln when you have e. Whatever you do to one side, you do to the other. ln, ln. So now you have this. You have ln of 1/2 equals negative kt. ln of e, but ln of e is just 1. Are we still okay? All right, next you just divide by negative k. I really don't like that negative k, tbh, but that's fine. I know a professor will probably say, what's decaying? And then I would reply with, let the situation tell you what k is, and then you can just find that k is going to be negative anyways. But whatever. All right. You can expand the ln of 1/2 from your log rules. This is ln of 1 minus ln of 2 over negative k. And then your negative will go away because ln of 1 is just 0, right? And then you have negative ln of 2 divided by negative k, which is just ln of 2 divided by k. And there it is. Your half-life just depends on the k value and not the nuclei present. Find the half-life and show that the half-life depends only on k. Yep, there's only a k in there. So this is your half-life. Half-life. Yay or nay? Okay. All right, don't worry. We'll finally do a real problem. Okay. Chab, why are you telling me this? Why is it important? All right, let's look at this question. And it says choosing a base. I'm not gonna choose a base. I'm just gonna say let's just use the base e. Then we'll choose a base once you feel more comfortable. And I had a kid who, and this was at Southside. It doesn't matter what the situation was. He just let the base be e, and he solved for k. Like, I don't care, Chav. If it's proportional, I'm just gonna use e. If you feel the same way, just use e. It'll work every time. At the beginning of the summer, the population hive of ball-faced hornets, which are actually wasps. Did you know that ball-faced hornets are wasps? Is growing at a rate proportional to the population. Right there, underline that. Growing at a rate proportional to the population. As soon as you see that, you're going to say, oh, okay, well, dy dt equals ky. So then that means y equals y naught e to the kt. Unless you want to do all this over again. See this. You don't have to do that over again. Once you know that it grows proportional to the population, if it's money or whatever, you can just go right into that. From a population of 10, so the initial population, I'm going to say y naught equals 10. On May 1st, to the number of hornets grows to 50 in 30 days. So my population in 30 days, so I'm going to say, let's just find it. All right, so 30, let's see what it says. If the growth continues to follow the same model, how many days after May 1st will the population reach 100 days? Okay, T is number of days. Number of days. So here we go. I'm going to write my amount equals the initial e to the kt. Do you guys remember when I told you let the issue tell you, let's see, from the population, let the situation tell you what your k is? Okay, so I'm going to solve for k first. So I'm going to say 100 equals, this is after 30 days, equals 10e to the 30k. And you're going to need a calculator. Does everyone have a calculator? Let me get a calculator. I'll wait for you guys. Okay. Is everyone okay with this statement? Did I confuse anyone with that one right there? The 100 came for after how many days? 30. So what am I doing right now? I'm solving for k. Solving for k. All right. So first move, divide by 10, divide by 10. What's 100 divided by 10? 10. 10 equals e to the 30k. Are we still okay? Next, I want to solve for k. So I need to bring that 30k down. What do I got to use if I want to bring that down? ln, ln. So now I'm going to bring that 30k down. And then look what I have. I have ln of 10 equals 30k. 30k ln of e, but ln of e is just 1. Okay, and I'm going slow, guys. Let me know if I'm going too fast. How do I get k by itself? Divide by 30, divide by 30. So ln, so k equals ln of 10 divided by 30. So let me tell you what that number is. I take my calculator here, and I'm going to go, let me see, should I use the alpha feature? Yeah, so let's not mess up here. ln of 10 divided by 30. And I'm going to store this to letter A. Store alpha A. It's growing, so that's why your K is positive. So there it is. That's your K. And I stored it to A. So I got, let's see what I got. 0.0767. 0.0767. It keeps going, and I stored it to A. I haven't done anything crazy. How many? Okay, all right. So now that I stored it to A, they want to know how long, let's see. How many days after May 1st will the population reach 100? Dang it, guys. How come you guys didn't tell me that the 100 is after? Oh, wait, it is. Okay. Did I just force it to be 30 days? Let me read it. I'm so mad. From a population of 10 on May 1st, the number of hornets grows to 50 in 30 days. What should the output have been? Not a 100. It should have been a what? 50. Just scratch it out and put 50. And what's let me see. How much damage did we do here? What's 50 divided by 10? 5. So change this to a ln of 5. So ln of 5. And then change the 30 to a what? After how many days? No, it's the number of hornets grows to 50. Oh yeah, that's fine. That's still 30. Okay, thank you. I was about to kill, like, do. Sorry, this equation, not anyone. All right, stop. All right, here we go. No harm done. Change the 10 to a 5 up here. ln of 5, because then I would have been faking a little bit when we would have done it the other way around. ln of 5 divided by 30, because it grows to 30. So there it is, 0.0536. So let me change that. 0.0536. Store that to A. Store alpha A. Okay. All right, now we got it. Everything's under control. We got everything correct now. So now here we go. Now I'm going to turn it to 100, and we're going to solve for time. So I'm going to go 100 equals 10E, and I have it stored as A, the K value. So I'm going to write AT, and I'm solving for time. The A is K, right? I found my K. The question is, how long does it take for me to reach a population of 100? So here it is. Divide by 10. So now this is 10. 10 equals E to the AT. And then how do I bring the AT down? ln, so ln, so the AT comes down. So now I have this. I have ln of 10 equals AT. That A is this one. Let me make sure that I stored it to A. Yeah, I did. All right, next, all I got to do is divide by A. So this is how long it takes for me to reach a population of 100. So I'm going to go ln of 10 divided by alpha A. And let's see what we get. 42.920. That's how many days? 42.920 days. So I would just say 43 days. Okay. And I'm going to change my color in a little bit. Let me change it to purple. No, let me change it to black. Okay. Do you want to see this? Maybe it's easier. I don't know. If you would have done it with a different base. I just want to show you that it doesn't have to be an E, guys. So this is why I call this a choosing a base. So let's go back and look at this. From a population of 10 on May 1st, the number of hornets grows to 50. So if I had an initial population of 10, I got to multiply 10 times what gives you 50? 5. So I'm going to put 5, and I'm going to put it to, let's see, in 30 days. So I'm going to write 1 over 30 times t. Okay, it works. And I'm going to say this is population. Chop, how did you know that? How did you turn that? The big deal is this exponential function here, guys. Look, if I made t equals 30 days, 30 times 1 over 30 is just 1. 10 times 5 is, what's 10 times 5? Does it work for that equation? Yeah, now check it out. I'm going to solve for t for 100, and I bet I'm going to get the exact same digit per digit. If I don't, that means I'm fake and I don't know what I'm talking about. And it better be the same because I'm not fake. So check it out, guys. I'm going to equal this to 100 equals 10 times 5 to the t over 30, and I'm just going to solve for t. So the first move, this is 10 times 5. I got to divide by 10. Divide by 10. So that's still the first move. 100 divided by 10 is 10 equals 5t over 30. Next, I want to bring the t over 30 down. So what do I do to bring it down? ln, whatever you do to one side, you do to the other. So now look what I get. I get this. ln of 10 equals, and this time I'm going to leave the ln of 5 there. T over 30 ln of 5. Next, I'll do it in 2 steps, guys, because I know sometimes if I do it in 1 step, I lose some of you. I'm going to get rid of that 30 down there by multiplying by 30. So here it is. So 30 ln of 10 equals t ln of 5. And then to get t by itself, I got to divide by ln of 5. So t equals 30 ln of 10 divided by ln of 5. Now, I bet you that this answer is the exact as that digit per digit. Let's find out. I take my calculator. I'm going to do I want that answer there, so I'm going to leave it there. Alpha y equals enter. And what did I have? 30 ln of what? 10 divided by, and let's see if it's the same digit per digit. And look at that. Different base, same answer, digit per digit. Are you not entertained? Are you not entertained, guys? It doesn't matter what base you use. So when you go to graduate school, when you start doing chemistry work, or you're looking at population growth, it might have to be a logistic. You BCers will do logistic before it's all said and done. You might have to do logistic, but in the very beginning, when it grows exponentially, it doesn't matter what base you use, you'll get the same answer no matter what. Looking at bacteria growing in the petri dish, a number of, it can be anything. Population growth of whatever, bacteria, rabbits, you name it. I thought that was cool. I don't know. You guys don't seem entertained. All right. Example 9. Last one, and then we'll call it a day. No new deltas. No new, so there it is. Yes, that one's coming up. This one. Differential equations. I don't remember, but it has slow field, so we still need to do one more lesson. We can't do it yet. All right, here we go. This is how they determine how old stuff is, guys. Carbon-14 dating. Not like dating as in date, but like dating date, Okay. C14, C16. Have you guys ever heard of those? These are called isotopes. Do you guys know? Or maybe I shouldn't go into okay. Scientists who use carbon-14 dating use 5,700 years for its half-life. Wow, look at that. Find the age of a sample in which 10% of the radioactive nuclei originally present have decayed. Okay, I like to solve for K again. That's just me. We don't have to. We can go right up to here and we can use this formula if you want. But I like to solve for K again. What route do you guys want to do? It doesn't matter to me. You want to do both? Okay, let's do both. You don't have to do both. I'm going to solve for K first. Solve for K. Obviously, look, you remember when I told you let the situation tell you whether K is positive or negative? So look, here it is. Half-life is 5,700 years, so I'm going to say this. 1/2 of the amount present equals y naught e to the 5,700 K. I'm just solving for K. See, solve for K first. Y naughts cancel out. I'm going to put ln, and I'll have ln of 1/2 equals 5,700 K. Divide both sides by 5,700, and I'm going to store that to A. So I'm going to take my calculator. See, that wasn't such a bad deal there. I'm just going to go alpha y equals ln. This is exactly what you're going to be doing in chemistry, guys. Well, it'll be easier. 5,700 And there it is. That's a really small number. Look at that negative. Obviously, it's negative because it's decaying, guys. Store it to A. Don't get tricked. That is not negative 1.21. Guys, there's 3 zeros in front of that 1. It's negative 0.000121. That's what it is. All right. So I'll put it in the notes just in case. Negative 0.000121. That's what it is, guys. All right. So here it is. I want, if 10% have declined, what percent do I have present? If 10% have decayed, yeah, you have 90%. So 0.9. Why not? What happened? I'm just solving for t now, right? Because they find the h to find the k. To find my k. This is my formula that I'm using. I'm using this formula. Yeah. 90% e to the at. I'm just solving for t. I have 90% present, guys. The why nots cancel. I'm going to use ln. ln of 0.9 equals at. Remember that ln of e is just 1. Divide by a. Time equals ln of 0.9 divided by a, which is, let's see what that is. ln of 0.9 divided by a. ln 0.9 divided by alpha a. Bam. 866 years. Dang. And this is how we find out how old stuff is. 866.417.